Since 1970, global biodiversity has declined by an estimated 70%, with climate change becoming a rapidly increasing threat. Heatwaves threaten drylands, areas that experience intense solar radiation and high temperatures, with a low vegetation cover and scarce water sources. The survival of many bird species in these areas depends on their ability to tolerate heat. As heatwaves become more frequent and intense, these birds' survival ability is being pushed to the limit. So which birds are likely to be at risk of extinction, and are we correctly estimating the impact of extreme temperatures on species? A recent study investigated the impact of heatwaves on dryland birds. So how can we determine which species are vulnerable? The study analysed bird species in 6 major dryland regions and defined heatwaves as at least 3 consecutive days of temperatures higher than 90% of historic levels. A species was considered to be significantly exposed when at least 25% of its distribution overlapped with a heatwave in a year. To measure vulnerability, the researchers scored 10 traits related to a bird's ability to regulate its body temperature from 1 to 6 by their sensitivity or adaptive capacity, and then averaged them for each species to obtain a susceptibility score. Species were then divided into 4 categories: non-significantly, significantly, highly, and extremely susceptible, where a matrix framework assessed species vulnerability by combining exposure and susceptibility. To assess the potential overlooked extinction risk, the number and percentage of vulnerable species were compared with the classification of extinction risk in the IUCN Red List. The groups critically endangered, endangered, and vulnerable were grouped as threatened, while near threatened and least concern were referred to as non-threatened. Finally, population trends were analysed following heatwaves using the Living Planet database. So what did they find? Heatwaves are becoming more frequent, with drylands experiencing them more frequently than the rest of the world, with the most affected regions being South America, Africa, Western Asia, and Eastern Australia. Over 80% of bird species were exposed to at least one heatwave within a single generation length, and over 90% are susceptible, with just under 75% deemed vulnerable. The most at-risk regions were Australia, Eastern Africa, and Southern Africa, where over 80% of bird species were vulnerable. Interestingly, over 90% of species identified as vulnerable are not currently considered threatened by the IUCN Red List. Additionally, vulnerable species showed faster population declines following heatwaves compared to non-vulnerable species and to the trends of any species following years without. However, when no heatwaves occurred, population trends between species were similar, reinforcing that heatwaves are the key drivers to these declines. So what does this mean? This study shows that heatwaves are already driving bird population declines, but species remain unrecognised as at risk by current conservation estimates. This reinforces a growing concern that climate change impacts are accelerating faster than we can track them, with extreme heat also affecting mammals and amphibians as seen in other studies. Over a third of bird species were exposed to at least 2 heatwave events in a single generation. When combined with other heatwave effects, like droughts and habitat loss, these repeated events make it difficult for bird populations to recover. Species classified as highly vulnerable should be prioritised for monitoring and risk mitigation actions, with Eastern Africa and Central Asia being key areas for future conservation projects as they currently lack research attention despite being heatwave hotspots. The discovery that over 90% of species classified as vulnerable in this study are not currently considered threatened by the IUCN is concerning. This suggests that current conservation frameworks are outdated, failing to capture climate risks, meaning some species could face extinction before they are even recognised as at risk. To improve conservation strategies, we need more research on birds' behavioural and physiological adaptations to extreme temperatures. This will help refine vulnerability assessments and ensure conservation efforts and resources target the species and regions most at risk. While this study has provided major insights into heatwave impacts, it is among the first of its kind, and so its methods and assumptions may need refining. One key limitation is that each trait was given equal weighting in measuring a species' susceptibility. In reality, some traits are likely to be more important than others for heat tolerance. This could mean that some species were overestimated in their vulnerability, while others may be at a greater risk than this study suggests. Additionally, the study did not consider behavioural or physiological traits which are crucial for understanding heat adaptation. For example, some birds may change their activity patterns or seek shade to cope with extreme heat. By omitting these factors, the study may overestimate the risk for some species and underestimate it for others. Heatwaves are already an active driver of biodiversity loss, and with potentially over 90% of heatwave-vulnerable bird species unrecognised by current conservation assessments, it is clear that previous frameworks are failing to capture the full impact of climate change on species. To reduce extinctions, conservation efforts must adapt by prioritising species and regions most at risk. This study provides the basis of development of a new framework for identifying climate-vulnerable species, but further research on behavioural and physiological traits is needed to refine this assessment. Protecting biodiversity requires proactive, data-driven conservation strategies, and so assessments must remain up to date to prevent the loss of species before they are recognised as threatened.